one of the major things you need to pay attention to, in addition to your chemical compatibilities with your atmosphere and heat curves through the material, is the overall expansion of your installation. And of course, expansion, we live in a three-dimensional world. Something gets hot, it's going to expand in all three directions, not just one of them. However, due to the overall dimensions of the furnace, you're going to have your greatest expansion, total expansion, in your longest dimension. So therefore, if you have a short dimension, which is your lining thickness, that's not usually a concern for expansion. It's going to, the total expansion through the depth of your anchor is not going to matter very much. So when you're designing, or when you're considering your clip system, you need to make sure you have enough design expansion in your overall installation. We can help you with that. Calculations for that are pretty straightforward. And then after you get the design expansion allowance, you need to make sure that the mounting system can accommodate that expansion. If you have rigid clips, but if you have enough expansion in your installation, you could still have a failure just because your clips can't move enough to accommodate the expansion that you already have. So when you are designing or when you're installing your system, just keep in mind that the roof installation is probably poses your highest consequences for failure. It's reliant totally on the roof anchor system as opposed to a wall, whereas you can rely on the support, the refractory right underneath it. If you have a catastrophic failure of one section of your wall, it's probably not going to result in the same failure that something in the roof would. You have, pull down adjacent sections. And of course, you have to make sure that your clip system can allow movement in two different directions, across the width and into and out of the furnace. So expansion considerations. When you're looking at your ceramic anchors, you're only considering reversible expansion in those, but that's not the major source of consideration. You're going to look at your monolithics that are in between the anchors, and for those you need to pay attention to reversible and the PLC, the linear. Oh, wrong way. Reversible and the linear change. When the monolithics bake out and get up to operating temperature, you're forming bonds. You're basically sintering the material together, so it's going to shrink some. And this is generally only on your first rise to operating temperature. After you get to operating temperature once and you come back down, your expansion joints open back up, and you'll only need to consider reversible expansion from that point forward. But for initial expansion calculations, you consider this and also the coefficient of thermal expansion. That's your reversible up here on the data sheet. And if you have a temperature range that you're looking at that's in between one of these values, you need to be able to extrapolate that. And again, that's a pretty simple calculation. We can help you through it. Just let me know if you have any problems with it.